let's drive the relation for the coplanarity of two lines in the Cartesian form. Now if lines x minus x1 upon a1 is equal to y minus y1 upon b1 is equal to z minus z1 upon c1 and x minus x2 upon a2 is equal to y minus y2 upon b2 is equal to z minus z2 upon c2 are coplanar, then what the formula is, then we can write it x2 minus x1 upon a1 y2 minus y1 b1 z2 minus z1 c1 a2 b2 c2 is equal to 0. Is it clear? If these are the two lines in the Cartesian form, then lines will be coplanar if determinant of this is equal to 0. Now the equation of the plane containing them is, now the equation of the plane containing them, that will be, if we are writing x minus x1 y minus y1 z minus z1 a1 b1 c1 a2 b2 c2 is equal to 0, or x minus x2 y minus y2 z minus z2 a1 b1 c1 and a2 b2 c2 is equal to 0. So we are having these things. Number one is, if the lines are coplanar, then this is the relation, and the equation of the plane containing them, that the equation can be formed if we are using either this one or this one. Is it clear? So now let's prove it. Now proof. Let x1 y1 z1 and x2 y2 z2 be the coordinates of the point A and B respectively. Now vector AB will be now x2 minus x1 with I cap plus y2 minus y1 with j cap plus z2 minus z1 with k cap. Let a1 b1 c1 and a2 b2 c2 be the direction ratios of any vector b and b dash, vector b dash respectively. Okay. Now then vector B will be represented as A1 I cap plus B1 j cap plus C1 k cap, and vector B dash can be represented as A2 I cap plus B2 j cap plus C2 k cap. Now the lines are coplanar if and only if vector AB and dot product of vector B cross product for vector B dash, cross product for, first of all, cross product for vector B and vector B dash with the dot product of vector AB is equal to 0. Okay. And this implies x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, a2, b2, c2 is equal to 0. Okay. So, this implies that one. Now, equation of plane containing them can be represented as x minus x1, y minus y1 and z minus z1, a1, b1, c1, a2, b2, c2 is equal to 0, or x minus x2, y minus y2, z minus z2, a1, b1, c1, a2, b2, c2 is equal to 0. So, this is in the Cartesian form.